Hello everyone. Let's solve few more questions on this module topic. So this is the one question. In this we have one top module, and in that top module we are using flip-flop module three times. So that is my D flip-flop. This is the flip-flop module name. Okay. So that module we are using three times. Okay. So here this top module there are two inputs. First clock and second one is D, and output is Q. Okay, so this is the top module, and in this MyD flip-flop module we have two inputs, clock and D, and output is Q. So let's see this question thoroughly. Here these two inputs going through this first flip-flop, and output of this first flip-flop going as an input for this second one, and output of this second flip-flop going as a input for this third flip-flop, and output of this third flip-flop is going as a output of this top module. Okay, so here this one acting as a wire, because this one is output for this first flip-flop but input for this second one. So we need to declare here wire, this one and this one, these two we need to declare as a wire. Okay, so let's solve this question. As input and output already declared, we need to declare wire. So wire W1 comma W2. Okay, both are 1 bits. Next, here we need to use that modules, small deep flip-flop modules in this top module. So module name, then instance name. So I am writing U1. Next, I will use positioning method. In the last video I discussed there are two methods, positioning and by naming we can write this module name. Okay, so in this flip-flop first clock, then D, then output. Okay, so in the same way I will write for this first flip-flop. So input are clock comma D comma, and output is Q, but we declare this one as a wire, right? So this name is W1. So W1 is acting output for this first flip-flop. Okay, so we need to write here W1. So this is for first flip-flop. Okay, similarly we need to write for second one. So we need to use different instance name. Same clock. In here in this second flip-flop, W1 is coming as an input. Okay, so in place of D we need to write W1, and at output side W2 is going as a output, so we need to write W2. Next, third instance name, here clock. See here W2 is coming as an input, so we need to write W2, and at output side Q is a output, so Q. Okay, so this is the code for this particular question. What we did, we wrote wires W1 and W2, then each flip-flop module we just call here, right, by using different instance name. Okay, so let's check it. So whatever we have written, that is correct. Okay, let's move to the next question. So this is a one more question. In here half of the question is same. There are three flip-flops and remaining things, this clock, D, and output is same, but here they use at the last flip-flop they use mux. Okay, not last flip-flop, output of this last flip-flop going through this mux, output of this second flip-flop it is also going through this mux, output of this first flip-flop it is also going through this mux, and what is the input that also going through this mux. Okay, so if you know this mux property and how it will work, then it is good. Otherwise, we will see these mux in detail in the upcoming videos. Okay, but I will try to explain here. So these things you already know, and here to write code for this mux, we can use this always statement. Okay, always block, and we can write this code for this mux. Okay, so let's write code for this question. See here, input little bit they change. In the previous question they have given only 1 bit input, but in this question they have given 8 bit input, 7 down 0. Okay, so let's write code. Here also same, we need to declare wire w1 and w2. So wire w1 comma w2. Next, same, my d flip flop u1. Next, clock comma d comma w1. Same, my d flip flop u2, clock comma w1 comma w2. Next, my d flip flop u3, sorry, clock comma w2 comma q. Okay, so that is for these three flip flops. Okay, sorry, here one more wire we need to declare, because this is also acting as a this pin is also acting as a wire. Okay, so we need to declare w3, and here we need to change a little bit in the third flip flop, here w3. Okay, next write code for this mux. So how we can write? We can use always block, always, sorry, always at the rate asterisk begin and end. See, here we use asterisk symbol, right? So what is the meaning of this? Whatever the signal change, if any signal changes, means this always block will execute. Okay, so that is the meaning of this. Now let's use a case statement, case selection. So here one selection line is also here, right? So they already declare here input 1 down 0 selection. Okay, so no need to declare. Next, here 2 tick d 0 0. What is the output? Output is q. Okay, so q, this is non-blocking operator. Next, what we are sending for 0 0 case, we are sending d. Okay, so d, 2 tick d. In the second case for 0 1, what will come for 0 1? See, for 0 0, this will go as a output. So in this place what is coming? D. So we wrote D. In 0 1 case, this will come, this pin. Okay, so what is this? W1. So W1. Okay, next, same. So I will just copy this thing here. In the third case means 10 case. Okay, so we have to write here 10. The 10 means 2, right? So here what will come? W2. So W2. Next case is 11 case. For 11, what will come here? Q. For 11 means this will go as a output. So it is this one W3, right? So W3. Okay. So this is the code for this mux. Okay. Any mistake we did? I think no. Our code is correct. See, this is the selection line. Based on selection line, whatever the coming here in this side, input side, that will go as the output based on the selection line. Okay. For 00 case, this 01, this 0 line is going as output. For 01 case, this line. For 10 case, this line, and for 11 case, this line. Okay. So that we already wrote here. Let's check it. Okay, we miss here in case. This case and in case are the keywords for this. Okay, I did one small mistake here. I wrote previously I wrote only 1-bit wire, but our input and here output also 8-bit. So we need to declare wire as a 8-bit. Okay, so I corrected those things here, where 8-bit W1, W2 and W3. And one more thing, I just wrote my D flip-flop initially, but here they wrote my D flip-flop 8. So we need to change it here. Okay, so be careful while writing this code. Now this code is run successfully. So in this way we can solve this module based question. Okay, we will solve a few more questions in the upcoming videos. Till that, thank you.